This is a NEET 2013 question from wave optics. The question says, in a Young's double slit experiment, slits are 2 millimeter apart. That means distance between the slits is given for us as 2 millimeters and are illuminated by the photons 2 of wavelength. So it was happened twice. First with a wavelength of 12,000 angstrom. Again second time with the wavelength of 10,000 angstrom. They are different cases, right? At what minimum distance from the common central bright spot on the screen 2 meter, that is screen is at a distance of 2 meter from the slit, the slit will be the bright fringe of one interference pattern coincides with the bright fringe of other. So what is being said here is, if you try to understand carefully, from the source light passed through Young's double slit experiment of slits S1 and S2. These slits are separated by a distance d, and on the screen, who is at a distance of capital D, there is an interference pattern formed. So it will be formed at a particular place. If it is a bright spot, then the distance is called something like fringe width. And we know the formula for the fringe width as beta equal to lambda into capital D by small d. So if you consider the first, when do I get that beta? For the first data, lambda 1 is given for you as 12,000 angstrom, has to be converted into meter, that is 10 power minus t. Distance between them is capital D as 2, by small d is given as 2 millimeter, that is 2 into 10 power minus 3. So this 2 and 2 will cancel, minus 3 becomes plus 3 on the top, 12,000 into 10 power minus 10 into 10 power plus 3. 3 and 3 is 6. So that will be 12 into 10 power minus 4 meters, that is 12 into 10 power minus 1 millimeters, that is 1.2 millimeter. So the first fringe width, first bright spot due to the first wavelength happens at a location of 1.2 millimeter from the central bright. The second will happen into 2, third will happen into 3, and so on. Similarly, if I continue finding out for the second data, for second wavelength, beta dash equal to lambda dash into d by d. Lambda dash is 10,000 angstrom. This time it is 10,000 angstrom. That is into 10 power minus 10. Everything else is same. By 2 into 10 power minus 3. This 2 and 2 will cancel. So this will become 10 into 10 power, this plus 3 and this becomes plus 3. So 10 into 10 power minus 6 will go minus 4. So 10 into 10 power minus 1 millimeter, that is 1 millimeter. So the bright spot due to the first wavelength happens at 1.2, first bright spot. Due to the second wavelength it happens at 1 millimeter. And they will be keep happening on the screen, second bright spot, third bright spot, and so on, right? So we can say, where does the two bright spots coincides with each other on the screen means 1 millimeter means sixth bright spot of here, this sixth bright spot. Where is that sixth bright spot location is? Each one is 1 millimeter, na? Is 6 millimeter from central bright, from central maxima. Here, where is the fifth bright spot? One bright spot is at 1.2 from the center, and 5 means 6 millimeter. So what we can say is, fifth bright spot due to first wavelength lambda 1 coincides with sixth bright spot due to the light of wavelength lambda 2, yet both the cases 6 millimeter from the central maximum. So the question is, what is question is, at what minimum distance from the common central, that is 6 millimeter, both the bright spots will coincide with each other. That's how we have to solve this problem. Thank you for watching.